Alright, class. This lesson shouldn't take too long. I promise it definitely won't be 20 minutes. So we're solving systems again by substitution now. This is a second method. The first method was by graphing, right? Finding that point where they intersect. And this method is substitution. Our goal is still to find a coordinate point x, y where they would meet. We're just doing it without a graph now. We're doing it algebraically. Okay, and so why don't you pause and just take a few minutes just to read through the procedure. So if you read through the procedure, it can be a little bit confusing, obviously, just reading directions. So let's just get straight into the examples, and then that'll be it for the lesson. So according to the procedures, the first step says solve one equation for the most convenient variable, right? If you look at, and you can choose whichever one you want. If you look at both equations, I have y is equal to x plus 3. Here's my line A, and then my line B. And if you notice, line A already has one of the variables by itself. It has y by itself. So I'm going to choose this one. Okay, and so what you're going to do is you're going to go to line B, and line B, I'll write everything in line B red. So it says x plus y equals 7. Now, since in line A we solved for y, we got y by itself, we can now substitute the y in line B with x plus 3, because in line A we are saying y and x plus 3 are the same thing, so we can literally substitute those things. So if we look at line B, what we just modified is we took x plus, and then instead of y we just did x plus 3 is equal to 7. Now what does that do for us? That actually makes it easier, because now we only have one variable. And so what would we do? We just combine, like, you can drop the parentheses. You can drop the parentheses there, and now we have x plus 3, and so if we combine like terms, you get 2x plus 3 is equal to 7, and then on both sides you'll have to subtract 3, and then you would divide by 2 on both sides, and your final answer for your x part of the coordinate is x is equal to 2. Okay, so you found the x part of the coordinate. Now what you're going to do is you can choose either line A or line B, and you're just going to plug back in the 2. And I'm going to put it back into A just because it's already y is already isolated. So I'm going to go back to A, and I'm going to do y is equal to, and I'm going to substitute again. Instead of x, I'm going to substitute 2 plus 3, 2 plus 3, and my y is equal to 5. And so my final coordinate point is 2, 5. This is the coordinate point where these two lines A and B, would intersect. And so that's what substitution is. If you feel like you can do the rest on your own, then pause and just kind of do the rest on your own. Otherwise, we could do number 2 together. Okay, number 2 here, neither line A or B have a variable by itself. So I'm just going to choose A, because there's a lot less things that I need to do here. So if I'm going to choose A, I have x plus y is equal to 15, and you can choose whichever one you want to get rid of. So I want to solve for y. I'm going to subtract x on both sides, and then I'm going to get y is equal to negative x plus 15. Okay? So now I'm going to go to B, and anywhere I see a y, I'm going to plug in negative x plus 15. So for B, 4x plus 3 times, oh, there's my y. I'm going to put a big old parentheses there, equals 38. And inside the parentheses, I'm going to plug in the y that I just solved for, negative x plus 15, and that's where it gets substituted from. I'll put an arrow there. And then go ahead now and solve for x. Why don't you pause for a sec, solve for x. If you solve for x correctly, then you should have gotten x is equal to negative 7. So negative 7, I know my coordinate point is going to be negative 7 comma something. And now it's time to find the y. So I'm going to plug this back into here. Okay? And it says y is equal to negative x plus 15. But instead of x, I'm going to plug in the negative 7 that I just found. Now, a negative of a negative 7 means that's just going to be a positive 7. So y is equal to positive 7 plus 15, and so that is equal to 22. My coordinate point where line A and line B will meet each other is negative 7 comma 22. Okay, the last one I'm going to do, or why don't you look for number 3 and decide which one you would do. Which one would you get, which variable would you get by itself from which equation? If you looked at line B and you recognize that x was almost already by itself, then that's pretty good. Okay, all you had to really do is get rid of that 4y by subtracting 4y on both sides, and so x is by itself here. And so what I'm going to do from line B, I'm going to actually substitute into A now. So I have 2 times my x minus 3y is equal to 4. Now instead of x, I just solve for x, and I'm going to plug in the negative 4y minus 9 into here. So take another minute, solve for y. After you have solved for y, you get y is equal to negative 2. And then, so my coordinate point is going to be something comma negative 2. And so with my x equation here, I'm just going to plug in negative 2 for y. So go ahead and do that and find your x. When you solve for x, you get x is equal to negative 1. So the coordinate point where line A and line B will intersect each other is negative 1, negative 2. Why don't you try examples 4 and example 5 on your own? And then I'll do example 4 first. You can check that, and then I'll pause, and then I'll show example 5. If you tried number 4, you'll notice that we ended up with 16 is equal to 6, which is obviously not a true statement. So what this is going to imply is that actually when you get y by itself for both lines A and lines B, you'll notice that they'll have the same slope, which means that they're parallel. And that means there is no solution here. This is an inconsistent system. Inconsistent system for number 4. Why don't you pause for a second, try number 5. So if you did number 5, you'll realize it's kind of the same as number 4, only we actually got a true statement here, 12 is equal to 12. The variables disappeared. And so what that means is that we have a consistent and dependent system, meaning it's these lines A and B are actually the exact same line. Okay, so if you have questions, come to class with them tomorrow, and then I'll try to clarify anything as best I can.